We can talk about it at the end. All right. For those of you taking the quiz, I'm recording the lesson so you can watch it at your leisure later. All right. So we are going to be starting the unit circle. Which the main reason that those of you that didn't take the quiz need to take it now is because once you learn the unit circle, you don't necessarily have to draw the triangles every time if the radius is going to be 1. And that happened on one of the quiz questions. So it's actually going to give us a little bit of a shortcut. And the new formula sheet you picked up, this will be the one you use on the next quiz. So it has some formulas on the back. It has your unit circle on the front. So the 6 trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, are all directly tied to the unit circle. So just like we did on our quiz where we had ordered pairs and we plotted the angle, the point, and then created a right triangle, you technically can create right triangles within the unit circle. Now why it's called the unit circle is that the radius is 1. Okay, so the hypotenuse, I should also say, would be representing the radius, which would always be 1. Which didn't always happen in some of the problems. Remember, it was like 7, 24, 25 was the hypotenuse. So that wouldn't necessarily work with the unit circle problems. But you'll see that the points on the unit circle are some of the most commonly used angles that you'll see. 30, 60, 90, and 45, and then all the way around to 360. So we know an ordered pair is represented x comma y. Well, the cosine in the unit circle is actually just the x coordinate, or the x value. The sine is the y value. Now, to find the tangent, remember the tangent is really the sine over the cosine. That was one of the formulas. We had 1 over cotangent or sine over cosine. So if the sine is the y value and the cosine is the x value, then the tangent is really y divided by x. And one way to remember them, so it's always like cosine comma sine, is that goes in alphabetical order, kind of like x and y does, so C and then S. And then for secant, of course, these are reciprocal identities. So this would be 1 over the x value, or flipping it. The cosecant would be 1 over the y value. The cotangent would be the cosine over the sine, which is the reciprocal of that, or x over y. So the directions, the problems below are going to look kind of similar to the ones we've done in the past. We're going to do the Pythagorean theorem, draw the picture, etc. The directions will be different because this is a unit circle approach. We're no longer doing SOHCAHTOA right triangle approach. We're looking at the unit circle. So you will see the point below is that is given is from the unit circle. So that's going to indicate that you're using the unit circle to find the values. You actually don't have to do any work for the sine and the cosine. Remember that the x coordinate is the cosine, the y coordinate is the sine. Again, this only works when the radius is 1 and when they or if they tell you it's a unit circle. So you just have to go write those down. No work required, you just have to remember it. So the sine is the square root of 3 over 2, and the cosine is 1/2. Literally just copying. Just don't screw it up, put those in the opposite spots, right? All right, now for the tangent, you will have to do a little bit of work. So the tangent equals y divided by x. Bless you. So we're going to take the y value, which is square root of 3 over 2, over the x value, which is 1/2. Some of you struggled with this in the rationalizing on your quiz. So you may want to take better notes. Okay? You can rewrite this division as a division symbol. So make it square root of 3 over 2 divided by 1/2. To divide fractions, we always multiply by the reciprocal. So we're going to change this to be the multiplication of the reciprocal, which would be times 2 over 1. And then these 2's will actually just divide out and go to be 1, so the answer is the square root of 3. Technically over 1 if you prefer. And then for our reciprocal identities, we of course have to flip them. Many of you did not rationalize yesterday. That is required for the problems. So this would be 2 over the square root of 3, which then needs rationalized. We would multiply by the square root of 3 in the top and bottom. In the top, you cannot multiply those because one's outside and one's inside the radical. But in the bottom, you would get the square root of 9, which then is 3. Secant's easy. It'd be 2 over 1, which is 2. And then for the tangent, to make your life a little bit easier, I would put it over there. Just do a pass.
No, I just came in.
Like from the office?
Like I just arrived.
I would take the reciprocal of the tangent that we have here instead of having to do all that work again. So just flip this, which would make it 1 over the square root of 3, and then rationalize that, which will get me square root of 3 over 3. These are the points that you're going to see the most often. You can see that their numbers are just switched around, but they all have the square root of 3 over 2 and 1/2. So you're going to see them so often, like some people just end up memorizing what the tangent of it is and being able to switch them around. You will no longer get to use your old formula sheet that tells you what the tangent is. Okay, so for the next quiz, you know how the chart on the back tells you what the tangent is. You'll now have to use the unit circle only to come up with it. All right, the next one. This is the other type that you'll see a lot, the square root of 2 over 2, which shows up at all of the 45-degree markers. Okay. So for this one, again, no work. Don't draw a right triangle. They want us to use the unit circle. So this is our x and our y. So this is our cosine, comma, our sine. 2 of our values are given to us. So positive square root of 2 over 2 is the sine. Negative square root of 2 over 2 is the cosine. And then to find the tangent again, tangent equals y over x. So that's going to again get me square root of 2 over 2 divided by negative square root of 2 over 2. Now before you start doing a bunch of work, think about it. If I were to tell you just 2 over 2, you tell me that's 1, right? Or 5 over 5, that's 1. 7 over 7, that's 1. Anything over itself always reduces to be 1. So because these are exactly the same, they're going to divide out to be 1, but since there was a negative in the bottom, it will be a negative 1. If you want to show the work, it'll all end up cross-canceling through division to get us a negative 1. But it's a lot easier if you just do it that way. Then, of course, we have to take our reciprocals. So this would be 2 over the square root of 2, which needs rationalized. 2 square roots of 2 over 2. If you put that, I'd probably accept it, but you can reduce that just one step further by dividing out the outside 2's to get just the square root of 2. Now the next one, you know it's going to be exactly the same, but it'll have a negative. So I'm not going to show the work because it's the exact same as the other one. And then this one, the reciprocal of negative 1 over 1 would be 1 over negative 1, which is still negative 1. Now on the back, they're going to ask us to use some of the periodic properties because some of the angles that they're going to give us are going to be greater than 360 or greater than 2 pi, which wouldn't show up on the unit circle. So we kind of have to use our periodic properties or our coterminal angles to help us find a number that would show up in the coordinate plane and in our unit circle. So the periodic properties, these are located on your note sheet obviously, but also on the back of the formula sheet. And basically they say, well, let me introduce what a period is. So the period of a function, specifically a trig function, we're going to get into this next week when we get back from break. We'll be looking at the graph of the sine function, which looks like this. And some of you may remember this from pre-calculus. Okay, it's an oscillation or wave. It just repeats itself over and over again. Follows the same pattern. So the period is how long it takes for it to repeat itself and then start giving you the same exact values over and over and over again. So the sine and the cosecant function, they start repeating at 2 pi, or 360 degrees. Okay. Same thing with the cosine and the secant. They start repeating after they've gone 1 full revolution. You'll start seeing the same exact ones. Now the tangent and the cotangent, there's a little dashed box around there because it's a little bit different. It'll start repeating at pi. How many degrees is pi? 180. Okay, now it also will repeat every 360, but you just have to subtract 180 from those numbers, or if it's negative, you would add 180 to those numbers. Okay, so using the periodic properties, find the exact value of each trig function. We're doing this now with the unit circle, no longer with our chart. So you want to kind of put that chart out of viewing range whenever you're doing your homework, because you don't want to get used to using that and then not have it on your quiz. All right, so cosine of 420, well, we can see that, and I hope you noticed that the degrees are located like closest to the origin in the unit circle picture, and then the radians is right next to it. So if you ever have to convert from radians to degrees, you could just look at the unit circle and go between the two for any of the reference angles we see. But 420 doesn't show up, so we're going to have to use the periodic property that it will repeat every 360 degrees, so basically using your coterminal angle. So we're just going to have to take 420 and subtract 360.
And you only use cosine because that's the one, that's the property.
Yes, cosine, secant, sine, and cosecant, those are all 360s.
Those are the only ones.
Okay. The tangent is going to repeat every 180, so you can just subtract 180 instead of 360. Okay, so we'll get cosine of 60, and at that point, we're going to go to the unit circle. Am I going to take the x coordinate or the y coordinate? What is the cosine? Cosine the x, or is it the y?
That's the one.
X. Remember that the coordinates are x, comma, y, and it goes cosine, comma, sine. Alphabetical, alphabetical. Okay. So that would be the x coordinate, which is 1/2. All right, the next one is the sine. Well, the sine is periodic or repeats every 360 degrees, so we'll subtract 360 to find the sine of 30. The sine is the y value of the 30 degrees. So we'll go to 30. The y value this time is also 1/2. And these two little blanks, just to fill them in, just tell you what I wrote up here. 2 pi is 360 and pi is 180. Can be used instead. Now, most of you don't like radians or subtracting 2 pi or pi and leaving it in terms of pi. So for these ones, many of you will want to convert first to degrees, at least from what I've seen in the past. You can, for this one, subtract 2 pi if you're going to keep it in radians. That's how you would do it. You would have to find a common denominator, which would be 4. So we would get, multiplying by 4, 8 pi over 4. 9 pi minus 8 pi would be 1 pi. So I find the radians just as easy as degrees, but some of you don't like that, and so I'll show it both ways. If you chose to do it this way, you go to pi over 4. Remember that the sine is the y value, so the y value is the square root of 2 over 2. All right, so that's using if you want to keep it in radians. Now, for those of you that like degrees, you have to take 9 pi over 4 and multiply by 180 over pi to get it in degrees. It's going to get us 405 degrees. And then to find something that's in the unit circle, because sine is periodic around 360, we would subtract 360 to get 45. You would go to 45 and look at the y value, which is also square root of 2 over 2. There were a couple of students on their last quiz that like just converted it to degrees and thought like that was their answer. No, that's only helping you to get to the answer. So make sure that if you're someone who converts from radians to degrees, that you actually complete the problem too. I don't care which way you do it, if you leave it in radians or if you change it to degrees, that's up to you. Now, the cotangent, if you remember our properties up here, the cotangent and the tangent are the ones that repeat about 180. So, you would actually be subtracting pi if you were doing it in radians, just 1 pi, which is 180 degrees. You would have to make a common denominator, so this would be 4 pi over 4. And sometimes you will have to subtract it multiple times. Do you want me to keep showing it in radians, or do you want me to show it in degrees? Which do you like better? Degrees. Okay. If you were doing this in radians, you would just keep subtracting 4 pi over 4 until you got to a number that's in your unit circle. Okay? Just like we did with coterminal, where you kept subtracting until you get a number that's in the unit circle. So if you want to convert this to degrees, we'll multiply by 180 over pi. That is on the formula sheet. In case you forget that formula, that is here, converting radians to degrees. You can reference that. And I'm going to get a big number. I'm going to get the cotangent of 765. All right, so what you're going to do is you're going to take 765 and you're going to subtract 180 instead of 360 because the periodic properties tell us that it repeats every 180. Now we will have to do this quite a few times until we get a number that is less than 360. And there we go, 225. So I just subtract it 3 times. And that's the cotangent of 225. So now we'll go to our unit circle, 225. How do I find the cotangent? If you're not sure, look back at the front. I have the cotangent equals what over what? Sarah? X over y. Alright, so we're going to take the x coordinate over the y coordinate. So the x coordinate at 225 is negative square root of 2 over 2 over negative square root of 2 over 2. Again, because we have the exact same thing in the top and bottom, they just cancel out and become 1. The 2 negatives would also actually cancel out to get me a positive 1. So the 2 negatives would form a positive tangent. Why don't you guys try E on your own and then we'll do F together because it's a little bit harder. Go ahead and give E a try. Secant is the reciprocal of the cosine. The cosine is the x value, so the secant is 1 over the x value. So we would go to our x value at 30 degrees, which is square root of 3 over 2. So I'll have 1 over the square root of 3 over 2. We can't leave our final answer like that because we have fractions within fractions. So what would I have to do to simplify that? Yes, remember this is division. This is like 1 divided by the square root of 3 over 2. If you need to show work, show the work. To divide something, you multiply by the reciprocal, 2 over the square root of 3, which will just get me 2 over the square root of 3. And then I have to rationalize. So we should get 2 square roots of 3 over 3. You also could have, instead of doing 1 over, you could just take this and you know the reciprocals to flip it. And that would save you this step. It would take you straight to there. Just like we used to do the chart and just flip it in our heads. You're welcome to do that for the secant, cosecant, or the cotangent. All right, now the last one we have here has a subtraction sign in the middle, so we're basically going to do each one separately. And then at the end, we'll subtract the answers that we get for each one. Now, first of all, this one has a negative inside of it. So you actually could just figure out what negative 5 pi over 6 is. Because we know negative goes down, right, instead of going up. So you could go like this is 1 pi 6, 2 pi 6, 3 pi 6, So 5 pi 6 would be over here. But the majority of you won't do that. So anytime you have a negative angle, you can actually go ahead and change it to a positive angle by adding instead of subtracting. So remember that tangent is periodic about the 180 instead of the 360. So most of you would probably want to convert this to degrees, but you could use the unit circle to see 5 pi over 6 is 150. So this would be like tangent of negative 150. All I did was I looked for 5 pi over 6. Since it's a negative, that would be a negative. Minus cotangent. Okay, 9 pi over 2 is not going to be in our unit circle, but we can figure out what it is. Which will get me 810.
I'm confused like why you did 150 and 810. Is it just kind of like convertible?
I converted them, yeah. So I did 9 pi over 2 times 180 over pi. I just left the pi's out because I know they cancel, so in the calculator I just did 9 times 180 divided by 2.
Yep.
All right, now since this one is a negative, again, we're going to have to add. In this case, we're adding 180 because cotangent and tangent are periodic about 180 instead of 360. So that will get me tangent of 30. Now, cotangent of 810, we're going to have to subtract 180 a couple times. So subtract it once. That's too big. Subtract it again. That's too big. Subtract it again. That works. So I subtracted 180 3 times. And I got the cotangent of 270. Anything under 360 will be in your unit circle. So the tangent of 30, we're going to go to 30 degrees. Remember that the tangent is y over x. Again, if you want to add that formula to your formula sheet, go ahead and do it. Some people also just like to memorize what the tangent is because it comes out to be the same every time. But this would be square root of 3 over 2 divided by 1/2. Oh, thank you. I know. Backwards. Now the cotangent is x over y. It's the reciprocal of that. So we'll go to 270. Make sure you don't miss 270. It is actually on the axis here. So x over y would be 0 over negative 1. Well, 0 over anything is just 0. So we're going to end up subtracting 0. So this is just going to end up going away. We just need to figure out what this is. So again, this is division. So 1/2 divided by square root of 3 over 2. Change it to multiplication of the reciprocal. 2 over the square root of 3. This time our 2's will divide out. But we still have to rationalize our final answer. So multiply by the square root of 3. And our final answer should be square root of 3 over 3. Technically minus 0, which is still the square root of 3 over 3. Why don't you guys give the closure a try while I'm...
So we definitely need a sheet for this.
You need the unit circle sheet. Yeah. Unless you want to memorize the unit circle.
I was talking about the formulas on the batch. We didn't go over today.
We went over the top section of them. That was it. Tomorrow we'll introduce some of the other ones.
Do we use any of them on the Hemwick?
Yes, just the periodic ones, which are basically that you add or subtract 360 to get a number that's in the unit circle, except tangent and cotangent you add or subtract 180. Because that's the function starts repeating values after 180 degrees instead of 360. Okay.